Hello everyone, this is Jing Wei. I'm very happy to introduce the Apache APISIX Ingress project. This is a simpler and easier Kubernetes Ingress. Here's something about myself. I'm Apache APISIX PMC, Apache Skywalking committer, and the founder of Apache APISIX Ingress controller. So what is Apache APISIX Ingress controller? It is another Ingress controller implementation based on Apache APISIX. And it supports declarative configuration, which can be configured through native ingress results or through custom results definition. We call it CRD. This picture tells us that the Apache APISIX Ingress controller is usually deployed at the edge of the cluster, serving as the cluster entry and forwarding business requests to the services. Well, we also need to introduce Apache APISIX. It is a high-performance, full-dynamic, real-time API gateway, and it is also a top-level project of Apache Foundation. This is the architecture diagram of Apache APISIX, and the left part shows us Apache APISIX how to process business traffic with rich plug-in functions. On the right is the controller plane of Apache APISIX. Here we mainly focus on admin APIs, through which Ingress controller synchronizes results to Apache APISIX. Okay, let's talk about the working mechanism of Apache APISIX Ingress controller. The Apache APISIX Ingress controller watches events from the Kubernetes API server, something like secrets, endpoints, and ingress in Kubernetes, as well as custom results definition, such as APISIX root, APISIX upstream, APISIX TLS, and so on. And then, the changed results objects are covered, compared, and finally, the results are synchronized to Apache APISIX cluster by invoking admin APIs. So, this diagram fully shows the relationship between Ingress controller and Apache APISIX. Apache APISIX Ingress controller is used as a controller plane to calculate and synchronize results configuration between Kubernetes and the APISIX cluster. Well, what can we do with Apache APISIX Ingress? I list many important features here, such as dynamic configuration, service discovery, flexible load balancing strategies, out-of-the-box health checks, traffic split, and more than 70 official plugins, as well as the configuration of custom plugins ability, and so on. Welcome to watch the project and get more future information. Let me show the path of Apache APISIX Ingress controller. In 2019, I wrote the first line of project and donated to the Apache Foundation in December 2020. After half a year of community polishing, the first GA version was released in June 2021. Until the last version 1.4 release, Apache APISIX Ingress has been used by more and more enterprises and working in production environments. Much has been learned along the way, and soon we will be releasing version 1.5 in mid-May. This is contribute growth curve of the Apache APISIX Ingress controller, and its steady growth shows that the project has maintained a good level of activity. Well, there is a question I think you will ask. We know that there are many Ingress implementations in Kubernetes, but why we still create another Ingress based on APISIX? Of course, as a gateway with excellent performance, Apache APISIX is necessary to implement Ingress in order to help users to use it on Kubernetes platform. Apart from that, we certainly have other reasons. That are why I recommend APISIX Ingress to you. First, all configurations of APISIX take effect dynamically, and there is no need to reload when the configuration is changed. Compared with some other Ingress implementations, using APISIX Ingress has natural advantages. Apache APISIX Ingress is easier to use. The declarative configuration is more readable, and complex scenarios can be defined in a single result. This example shows that an API is assigned to different upstream according to weights. Of course, that certain conditions must be met. Here we can see that the complex traffic split configuration are delivered into two parts, match and backend. The match part defines the route matching rules, and the backend part defines the weight between upstreams. The whole configuration is very easy to read. Third, APISIX have strong scalability. Following the above configuration, if you want to add some features to this API, such as the ability to support cross-domain and URI rewriting, we can use plugins to empower the API. If you want to add more features, just add plugins. I'd like to say that the design of the plugin is very compatible with the declarative configuration. And because of the encapsulation of plugin, you do not need to write code sleeved in declarative configuration, and no longer need to pay attention to these code logics. The only thing need to be cared about is some simple variables, which is more general and more readable. Okay, let's come back and talk about the flexibility of the architecture of Apache APISIX Ingress controller. Apache APISIX Ingress does not combine controller and proxy like other ingresses. The advantage of this is that you can deploy them together or separately. When Ingress controller and APISIX are deployed together, they are used to handle ingress requests to a single Kubernetes cluster, no different from traditional Kubernetes ingress. You can also deploy them separately. This is awesome. As shown on the right, APISIX cluster is deployed outside the Kubernetes clusters and can manage the traffic of multiple Kubernetes clusters. In this way, all resources be managed in unified APISIX cluster and also reduce one traffic forwarding. The only thing you need to care about is the networking between the Kubernetes clusters. Here are some complaints using Apache APISIX. More and more enterprise customers are using Apache APISIX for production environments. More and more users are adopting Apache APISIX Ingress solutions. That's what keeps our open source project going. Okay, I'd like to share with you the future plans of Apache APISIX Ingress controller. We are supporting the Kubernetes Gateway API, and we are also preparing to support a new scenario, which is to support cluster deployment without etcd. I think users who mind etcd being stateful will be happy to hear about that. Why we made such changes? Because these needs from the community are very reasonable, and this is the driving force for the project to continue. Okay, The above is the whole content of this sharing. Looking forward to build Apache APISIX community together with you. See you next time.